So, if you knock on the desk in front of you right now, standard quantum mechanics basically insists that you're mostly interacting with empty space.
Yeah, the classic void.
Right. The traditional textbook model tells us that the atoms making up that wood are just these infinitesimally small points of mass, and they're separated by these vast, unbridgeable voids.
Which is pretty counterintuitive when you think about it.
Exactly. And we've just spent the last 100 years accepting this void as absolute gospel. But we're diving into Sriman Barua's new manuscript today, which outlines the absolute medium framework, or the AM framework.
And he just completely throws that void concept out the window.
He really does. I mean, Barua states categorically that there is absolutely no empty space anywhere in the universe. That solid table you're knocking on, it's just the continuous fabric of the universe violently fighting back against the atoms in your knuckles.
Yeah, the manuscript really demands a complete conceptual teardown of classical physics.
So that's our mission for this deep dive. We're going to test the absolute limits of Barua's tension net.
Which is a great name for it, honestly.
It really is. The goal here is to scrutinize how a purely continuous, fluid-elastic medium can allegedly explain, well, everything, from the physical hardness of a diamond to why a galaxy rotates, and doing it all without invoking standard crutches like dark matter.
Or gauge bosons, right.
Yeah.
We are so used to the billiard ball model of reality, discrete particles floating in a passive vacuum, interacting through these invisible mathematical exchange forces.
Right, like shooting tiny gravitons at each other.
Exactly. But Barua's AM framework posits that the universe is just a singular, unbroken, fluid elastic tensor field, the tension net.
Okay, so let's start with the most basic building block then. Standard model physics relies on discrete elementary particles like quarks and electrons. If there are no discrete billiard balls in this framework, how does Barua even define a single atom?
Well, he defines it as a topological knot.
A knot, like in a shoelace.
Kind of, yeah. Imagine the tension net as this three-dimensional, infinitely continuous, highly elastic matrix. In Barua's math, a particle is simply a region where this continuous matrix has just folded in on itself to an extreme degree.
So it's a localized point of intense structural strain.
Exactly. You cannot remove the knot from the net because the knot literally is the net.
Which is wild, but I guess that immediately solves the classical action at a distance problem, right?
It does. Things don't need to shoot invisible gravitons at each other through a void to interact because they are already physically connected. The continuous medium extends between their respective knots.
I mean, I get the geometric appeal of replacing particles with knots, but it creates this immediate mechanical contradiction for me.
How so?
Well, if my hand and the table are both just folded regions of the exact same continuous medium, what stops my hand from just passing right through the table?
Right, the phasing problem.
Yeah, because in the standard model, we rely on Pauli's exclusion principle and electrostatic repulsion between electron clouds to explain why solid objects don't just phase through one another. So what is Barua's mechanical substitute for physical hardness?
So Barua replaces electrostatic repulsion with what he calls the Non-Linear Elasticity Principle, or NLEP.
NLEP. Okay, what does that do?
It governs how the tension net responds to being deformed. So the baseline medium strongly prefers to be flat. It wants a relaxed geometry.
Like a perfectly stretched bedsheet.
Right. When a localized region folds into one of these topological knots, the local energetic strain just skyrockets. The medium fundamentally resists this folding.
So it pushes back.
Violently. It generates this immense restorative outward pressure that Barua defines as the Dissociative Pressure Field, or DP field.
Okay, so the DP field is basically the net trying to violently untie the knot.
That's a great way to put it. It is the localized structural tension fighting to return to baseline zero. But the critical factor here is the nonlinearity.
What do you mean by nonlinearity in this context?
Well, as the medium folds tighter and tighter toward the core of the knot, the resistance doesn't just increase at a steady linear rate. The NLEP equations suggest the stiffness of the medium scales to the inverse fourth or fifth power of the radial compression.
Yeah, hold on. Let me stop you there, because an inverse fifth power scaling means the resistance effectively hits a brick wall almost instantly at a certain threshold.
It absolutely hits a brick wall, and that threshold is actually the mathematical core of the whole AM framework. Barua denotes it as epsilon max.
Epsilon max, the point of absolute topological saturation.
Exactly. At the very center of the particle knot, the medium is folded so tightly that it simply cannot be compressed even a fraction of a Planck length further.
Because it would tear the net.
Right, it would violate the structural continuity of the universe, so it becomes perfectly stiff. It's dynamically frozen.
Okay, that explains the core of a single isolated particle. But it doesn't really explain the macroscopic hardness, the table I'm knocking on.
Sure it does, just on a larger scale.
But if I press my finger into the wood, I'm not directly touching the frozen core of a single atomic knot, right? I'm interacting with trillions of them at the same time.
True. So when your finger approaches the table, the outermost NLE boundaries of the atoms in your skin begin to overlap with the NLEP boundaries of the atoms in the wood.
Okay, so their respective fields are interacting.
Right. You are trying to force two highly saturated, infinitely stiff spatial regions into the exact same coordinate space. And because that dp field resistance scales so violently, the medium between those atoms pushes back with a macroscopic force that basically approaches infinity.
So physical hardness is literally an illusion.
Completely. You aren't feeling the solid substance at all. You are feeling the steep NLEP stiffness boundary of a continuous field violently refusing further localized compression.
Wow. So the table is just the zone of extreme structural tension that forbids my hand structural tension from entering?
It's localized field repulsion, yeah. But it's grounded in fluid elastic mechanics rather than, abstract electromagnetism.
Right. Okay, but if we follow that logic, it raises a pretty big thermodynamic problem.
Let's hear it.
Well, if everything is just a topological knot fighting against the dp field, how do we account for the different states of matter? Like, the air in this room is a gas. I could just wave my hand right through it.
Right.
But if air molecules are also knots with these saturated epsilon max cores, why doesn't the NLEP boundary of the air fight my hand the way the wood does?
That comes down to the baseline medium between the knots.
Okay, unpack that for me.
So in a gaseous state, the topological knots, the gas molecules, they're widely distributed. The spatial distance between them is governed by the relaxed, linear, elastic regime of the tension net.
So it's not compressed yet.
Right, it's highly compliant space. When you move your hand through the air, or if you compress a gas in a piston, you aren't forcing those steep NLEP stiffness halos to overlap.
Oh, I see. I'm just pushing the knots around within that soft baseline medium.
Exactly, you are just displacing them. It requires minimal structural force because those frozen cores aren't interacting directly yet.
Okay, that makes perfect sense for gases. But what about liquids? Because liquids and solids are both fundamentally incompressible on classical physics.
Very true.
Like, if I try to compress water in a sealed syringe, it fights back just as hard as a solid block of wood.
Yep.
So the AM framework would argue this is because the knots in both the water and the wood are packed so tightly that their NLEP halos are actually touching, right?
In direct physical contact, yes.
But why does water flow around my hand while wood shatters or stops me? If their halos are touching in both states, what differentiates a liquid from a solid?
That brings us to what the manuscript defines as interknot strain geometry.
Interknot strain geometry. Okay, that sounds intense.
It's actually pretty elegant. It isn't merely about proximity. It's about how the localized dp fields of adjacent knots merge and share their structural strain.
So how they connect with their neighbors.
Right. In a solid, the geometry of the topological knots aligns to form these deep, highly symmetric strain wells.
Okay, let's define a strain well mechanically. Because in classical physics, we talk about potential energy wells, where atoms rest at a minimum energy distance. Is it like that?
It is the exact fluid elastic equivalent of that. The continuous medium always wants to minimize overall structural stress.
Right, the laziness of the universe.
Exactly. When these knots lock into a specific symmetrical lattice, their overlapping dp fields actually cancel out localized stress points. This creates a deep macroscopic energy minimum.
So the net finds a really efficient configuration to hold them together.
Yes. Barua calls this a topological lock. The knots become trapped in this rigid structural tension. That is what constitutes a solid state.
Got it. So if a solid is a topological lock trapped in a deep strain well, then a liquid must be a state where the knots are tightly packed, hence why they are incompressible, but they lack that symmetrical geometric locking.
You nailed it. The structural tension bonds between liquid knots are incredibly shallow.
Because they can't find that perfect symmetry.
Right. Whether it's because of their kinetic energy or their specific shape, they can't establish deep strain wells, so the knots are just constantly sliding past one another, seeking paths of least resistance through the ambient medium's stress field.
Rolling over each other.
Yeah. The manuscript actually characterizes a liquid as floating matter in a flowing medium. The bonds continuously break and reform without ever locking the macroscopic structure into a rigid grid.
Okay, so that brings up phase transitions, like melting and freezing. The standard model explains phase transitions like ice melting into water purely through kinetic theory.
Heat makes things vibrate.
Exactly. You add thermal energy, the molecules vibrate faster, and eventually that kinetic energy just overcomes the intermolecular bonds. But how does the AM framework handle temperature?
Wow.
I mean, in a continuous fluid elastic medium with literally no empty space, what actually is heat?
Temperature, in the AM framework, is basically the macroscopic manifestation of high-frequency vibrational strain waves rippling through the tension net.
Vibrational strain waves.
Yeah. Heat is not some independent property. It is a specific type of mechanical distortion propagating right through the fabric.
So injecting heat into a block of ice isn't about the water molecules absorbing thermal energy in some abstract sense.
No, not at all.
It's about subjecting that topological lock to violent mechanical oscillation, like shaking an egg carton so violently that the eggs just bounce out of their divots.
That's a brilliant analogy. The vibrational strain waves force the locked topological knots to physically oscillate against their steep NLEP boundaries. And as the temperature rises, this kinetic oscillation gets more violent.
Until the bonds just give up.
Exactly. The structural agitation finally exceeds the binding threshold of those deep symmetrical strain wells. The rigid tension connections snap.
The topological lock is destroyed.
And the knots are forced out of those deep energy minima and into the shallow dynamic flow state of a liquid.
That's fascinating. I mean, standard kinetic theory models that adequately, but Barua's model maps the exact same outcome onto the physical degradation of a tensor field's geometry.
Right, it's purely structural.
So freezing, then, is simply the dampening of those vibrational strain waves. As the local medium bleeds that mechanical oscillation into the surrounding environment, the underlying stiffness of the DP field regains control.
Yes. It forces the knots back into the deepest available symmetric strain wells to minimize localized stress.
It perfectly bridges the microscopic tensor mechanics with macroscopic thermodynamic behavior. I'll concede the phase transitions, that makes sense. But the AM framework faces a massive hurdle when we look at the structural consistency of different solids.
Okay, lay it on me.
Let's compare a pane of glass and a copper wire. They are both solids. They are both, in Barua's terms, topological locks sitting in deep strain wells, right?
Correct.
Yet if I apply macroscopic shear to the glass, if I hit it with a hammer, it catastrophically shatters. But if I apply the same shear to the copper wire, it smoothly bends and just holds a new shape.
Malleability versus brittleness.
Exactly. Standard chemistry explains this via covalent networks versus metallic bonding, right? The sea of electrons in the copper. But if Barua is abandoning electron clouds, how does a purely fluid elastic medium dictate why one lock shatters and another bends?
The manuscript addresses this by completely redefining molecular bonding. He defines bonds as continuous circuits of advective flow.
Advective flow, like a current.
Yes. The topological knots aren't just sitting statically in their strain wells, they are actually surrounded by an active layer of the medium that is continuously circulating. We will get to the exact mechanics of that circulation in a bit.
Okay, so they have a circulating skin.
Right. When atoms form a bond, the DP field forces these atomic vortices to align their ingress and egress currents. The flowing medium around one knot physically merges with the flowing medium of its neighbor.
Oh, wow. So they create a closed macroscopic circuit. It's literally an active plumbing system of moving medium rather than just a static bridge between two objects.
Exactly. Now, in brittle materials like covalent crystals, so your pane of glass, these continuous circuits lock into intensely rigid, highly specific geometric pathways.
Like rigid train tracks.
Perfect comparison. The flow lines are strict and inflexible. When you apply macroscopic shear to the glass, you are attempting to force the knots out of their highly specific flow alignment.
And because the NLEP boundaries in a brittle crystal are so steep and the flow circuits are so isolated, the flow lines just can't smoothly detach and reattach to a new neighbor.
They can't. The structural tension exceeds the local elastic limit, and the localized circuit violently severs.
And because its structural integrity relies on those specific isolated loops, the entire macroscopic lattice propagates the fracture. The train derails, and the glass shatters.
Exactly. Now contrast that with malleable materials like copper. In metals, the atomic vortices do not form isolated, rigid flow loops. The geometry of their strain wells allows them to share a continuous, collective, advective flow across the entire macroscopic structure.
Oh, I see. So it is the fluid elastic equivalent of the classical electron sea. It's a shared global flow line, like a multi-lane highway instead of a rigid train track.
Precisely. And if the flow line is globally shared rather than rigidly localized, macroscopic shear shouldn't sever the circuits.
Because if I strike the copper with a hammer, displacing a cluster of atomic knots, the shared advective flow just dynamically deforms around the new configuration. Traffic just reroutes around the blocked lane.
The global flow line dynamically reroutes. But more importantly, the immense restorative pressure of the DP field heals any minor topological disruptions almost instantly.
Because it's already acting as a collective pool of flow rather than rigid singular tracks.
Exactly. So the metal can bend, stretch, and deform, instantly reestablishing stable circuits without ever violating the macroscopic structural integrity.
Okay, that is incredibly elegant. But wait. That implies a continuous, permanent state of active flow circulating around every single atom in a piece of metal or glass or my own body.
It does.
This brings us to a glaring thermodynamic paradox in Boa's manuscript. I mean, if there is a permanent advective flow of the tension net circulating around every topological knot, and the DP field is constantly maintaining this immense, crushing pressure to sustain that epsilon max core.
I know where you're going with this.
How is this not a massive violation of the conservation of energy? Standard physics says particles don't just consume energy to exist. An engine running constantly must burn fuel. How does the AM framework avoid the perpetual motion paradox?
This is the precise reason Barrow mandates a strict anatomical division of the topological knot. It's divided into two distinct regions, the frozen core and the active skin.
Okay, break that down.
He strictly isolates static structural geometry from dynamic kinetic flow to maintain thermodynamic closure. Let's look at the frozen core first. We already established it as topologically saturated to the epsilon max limit, right?
It's a brick wall.
So the frozen core does not perform any thermodynamic work to remain stiffened. The extreme structural strain of that central fold is stored entirely as static potential energy.
Wait, how did it get that energy in the first place?
During the initial creation of the particle, maybe in the immense pressures of the early universe or inside a supernova, kinetic energy was forcefully expended to overcome the linear elastic limits of the baseline medium.
Oh, I see. And once the medium reached that absolute saturation point, it just locked into a deep local energy minimum.
Exactly. The kinetic energy required to fold the net was perfectly converted into locked potential energy. The core is permanently deformed.
It's like a coiled spring trapped inside a welded steel box. It doesn't require active energy to stay coiled because the geometric lock prevents it from uncoiling.
That's spot on. And because it is permanently locked in this highly compressed, saturated state, it permanently displaces topological volume from the surrounding baseline tension net.
Meaning the surrounding medium has been pulled, taut, to supply the fabric for the core's knot.
Yes. This generates a permanent structural tension gradient in the surrounding DP field. The surrounding net is stretched.
And the NLEP rules dictate it violently wants to return to a flat baseline.
Right. So the stretched medium continuously attempts to slide down that static geometric slope to crush the knot out of existence and return the local volume to zero strain.
Okay, so this continuous restorative elastic contraction is the AM mechanical origin for the advective draw, which means,
Connect the dots?
advective draw, that's gravity.
Correct.
So gravity isn't a particle actively consuming energy to pull mass toward it.
No.
Standard relativity models gravity as the curvature of spacetime, which is conceptually similar, but lacks a physical medium. In Barua's model, the draw is simply the ambient medium continuously attempting to slide down the static tension gradient created by the permanent volumetric displacement of the frozen core.
That's exactly it. The core isn't doing any work. It is entirely passive. It is just a structural void in the relaxed field.
But this creates the other half of the paradox. If the ambient medium is continuously rushing inward to crush the core, why doesn't it pile up infinitely? I mean, the core is frozen and impassable. The medium must go somewhere. In fluid dynamics, if a high-pressure flow hits an impassable spherical barrier, you get violent cavitation or deflection.
And you get deflection here too. In the AM framework, as the inward rushing ambient medium, the ingress, impacts the impenetrable wall of the epsilon max core, the radial pressure is frictionlessly and perfectly converted into angular momentum.
Frictionlessly?
Yes. The medium is violently deflected sideways, forced to circulate around the saturated boundary. This forced continuous diversion creates a self-inducing circulation of energetic strain.
And this circulating outer layer is the active skin. It forms a perpetual vortex around the core. Radial ingress converts to angular egress, shielding the core.
Exactly.
But again, standard thermodynamics forbids perpetual motion without energy loss to friction or heat.
But standard thermodynamics applies to dissipative systems with internal friction.
Okay.
The tension net is defined as a fundamentally continuous, purely elastic medium. The active skin operates as a perfectly closed kinetic circuit.
Because there's no friction.
Right. The inward crushing force of the dp field is perfectly balanced by the outward centrifugal advection of the circulating skin. Because the medium cannot fracture and possesses absolutely no independent internal particulate friction, the dynamic kinetic energy of the circulating active skin just remains constant.
Wow. So the total energy of a particle is simply the static potential energy of the frozen core plus the constant dynamic kinetic energy of the active skin vortex.
Yes.
The system is thermodynamically closed. It's just a permanent stress state of the universe. I mean, I follow the internal logic of the math, but this model creates catastrophic problems for macroscopic mechanics.
Specifically regarding motion.
Precisely. If I am made of trillions of these knots,
Uh-huh.
and these knots are not discrete objects, but literal permanent folds in the continuous unbreakable fabric of the universe,
Yeah.
how can I possibly walk across the room?
It sounds impossible.
In a classical vacuum, a discrete mass just translates its coordinates through empty space. But if the AM framework is true, walking across the room means I am forcibly dragging the very fabric of the universe with me. The viscous drag should be infinite. Macroscopic motion should be completely impossible.
It would be impossible if motion in the AM framework meant dragging the local medium across the universe. But Barua resolves this paradox by demanding a complete abandonment of the classical concept of kinematic motion.
Okay, so how do I move?
Macroscopic bodies do not travel through the medium. Motion is redefined strictly as topological propagation.
Propagation, that implies a wave.
Yeah.
Standard model physics accepts wave-particle duality for quantum states, but you're arguing my macroscopic biological body moves purely as a wave phenomenon.
Your body is a highly synchronized, multi-layered collection of flow circuits. It's a complex topological wave packet.
Okay.
When you move, the actual localized substance of the tension net making up your knots in this current second does not travel to the other side of the room.
Wait, really?
Really. Instead, the geometric pattern of extreme structural strain, the state of being folded, propagates through the continuous matrix. Berdua explicitly likens it to a soliton wave or a slip defect moving through a crystal lattice.
Let me try to visualize the mechanics of that.
Yeah.
So as my hand moves forward, the relaxed linear elastic baseline medium immediately in front of my hand must violently fold into extreme structural strain, rapidly becoming the new epsilon max cores and active skins of my atoms.
Yes.
And simultaneously, the medium immediately trailing my hand must instantly unfold, relaxing back to the baseline zero strain state. So my atoms aren't actually moving. They are continuously unzipping and rezipping the local tension field.
You are the geometric epicenter of a continuous localized reconfiguration of the dissociative pressure field. You never actually leave the net. You are just a propagating state of structural tension, like the wave at a sports stadium.
Well, that's good. The fans themselves don't run across the bleachers. The people just stand up and sit down. But the shape of the wave moves across the stadium at high speed. But even if I accept that motion is propagation, the thermodynamic problem is still there. Constantly folding and unfolding the universe at trillions of points in my body, every millisecond should require astronomical amounts of work.
It would seem so.
If the dp field fiercely resists folding, the structural drag of propagation should decelerate any moving object instantly. How does the AM framework explain Newtonian inertia? Why does an object in motion stay in motion?
Barua addresses this head-on with the Partial Saturation Coupling Theorem.
What does that do?
This theorem isolates exactly which part of the topological knot is performing the fluid elastic work of propagation. We established that the frozen core is topologically saturated to the extreme limit, right? Epsilon max.
Yeah.
Because it is saturated, it is dynamically frozen and cannot process any new advective flow. It is structurally inert.
Okay, so it doesn't do the work.
Exactly. Consequently, when the topological wave packet propagates, the massive saturated core does not actively interact with the ambient medium's resistance. It simply shifts its geometric coordinates within the net.
So what does do the work?
All the fluid elastic work required to fold the leading edge and unfold the trailing edge is managed exclusively by the unsaturated transition zone, the incredibly thin active skin.
Okay, so the active skin acts as the buffer, shielding the core from the structural drag of the unzipping process.
Precisely. And the mathematical linchpin of Barua's inertia mechanism here is the active volume fraction parameter. It's denoted as F active.
F active.
The manuscript calculates that the volume of the active skin relative to the volume of the frozen core is exceptionally small. It operates on the order of 10 to the negative 14.
10 to the negative 14. That means only 1/100 trillionth of the particle's physical volume is actively engaging the structural resistance of the ambient medium during propagation.
Exactly. And because the F-active parameter is so infinitesimally small, the structural resistance to constant velocity propagation effectively approaches zero.
That's amazing.
The active skin seamlessly severs the baseline flow lines, diverts them around the shifting core coordinate, and reconnects them at the trailing edge. This virtually frictionless fluid elastic unzipping is the literal mechanical foundation of classical inertia.
So the medium provides almost zero structural drag, allowing the packet to maintain its propagation velocity indefinitely.
You got it.
But you said almost zero structural drag, not absolute zero. Which brings us to acceleration and the speed of light.
Ah, relativity.
Right. Standard special relativity dictates that as an object approaches the speed of light, its relativistic mass increases toward infinity, requiring infinite energy to accelerate further. We view it as a fundamental geometric property of spacetime. But as the AM framework discards standard spacetime geometry, how does it physically enforce the speed of light limit?
The framework enforces it strictly as a fluid elastic mechanical threshold.
Mechanical, not geometric.
Right. As a macroscopic body accelerates, the rate at which that incredibly thin active skin must fold and unfold the incoming medium drastically increases. The active skin must process the leading edge advection at higher and higher frequencies.
Makes sense.
However, the continuous medium possesses a finite maximum coherence propagation speed. Barua denotes it as CAM.
So CAM is the absolute physical limit of how fast the tension net can mechanically restructure its topology without tearing.
Correct. It is the structural speed limit of the continuous tensor field. As a body's propagation velocity approaches CAM, the medium preceding the active skin physically cannot fold rapidly enough to accommodate the required topological displacement.
The unzipping mechanism begins to lag.
Yes.
The active skin is essentially outrunning the universe's ability to get out of its way. And if the medium can't fold fast enough, the local dissociative pressure must just spike exponentially at the leading edge.
It does. That DP spike generates literal, massive structural drag on the active skin. It acts as physical fluid elastic resistance to further propagation. This is the AM framework's mechanical driver for what classical physics abstracts as relativistic energy mass saturation. It completely strips away the abstract geometry of Lorentz transformations and replaces it with a highly physical structural limit on the rate of continuous topological reconfiguration.
It literally turns relativity into a fluid dynamics problem.
It really does.
And I assume this minuscule non-zero drag at sublight speeds is how Barua explains the Pioneer anomaly.
Oh, good catch. Yes.
Because for decades, standard orbital mechanics couldn't fully explain why the Pioneer spacecraft were experiencing this minute, unexplained sunward deceleration as they left the solar system.
Right. Standard physics tried to patch the Pioneer anomaly with thermal radiation pressure models, but the AM framework provides an explicit mechanical cause.
Because of the advective parameter.
Exactly. At macroscopic scales and high orbital velocities, the spacecraft acts as a massive topological wave packet, pushing through the ambient advective flow of the solar system. Because F-active is non-zero, it experiences minute but cumulative fluid elastic friction over vast distances.
The tension net is quite literally applying microscopic structural brakes because of the effort required to continuously reconfigure the topology at high speeds.
It is a profoundly elegant, purely mechanical solution. It removes the abstraction from astrophysics.
Let's scale this up even further then. We have mapped the mechanics of inertia and propagation. Let's look at the largest structures in the universe. Galaxies. This is where standard astrophysics relies on its biggest, most controversial crutch, dark matter.
Oh, the standard model of galactic rotation is fundamentally broken.
Yeah, it really is.
When we measure the orbital velocities of stars at the outer edges of spiral galaxies, they are moving far too fast. Based on the visible mass of the galaxy, the gravitational tether just shouldn't be strong enough to hold them. They should be flung out into deep space.
And to save the math, standard astrophysics hypothesized this massive halo of invisible, undetectable matter, dark matter surrounding the galaxy, providing the extra gravitational mass needed to keep the stars in orbit.
Which we've never found.
Right. We have spent billions of dollars building subterranean detectors trying to find a dark matter particle,
Yeah.
and we have found absolutely nothing. So how does the AM framework eliminate the need for dark matter?
It eliminates the need by applying the exact same fluid elastic principles we just used for the single particle, just scaled up to a cosmic macroscopic basin.
Okay, remind me.
We established that gravity is the continuous medium attempting to slide down the structural strain gradient created by a frozen pore. A star or a planet is simply a massive aggregate of these topological sinks.
A colossal drainage basin in the local DP field.
Precisely. Now, aggregate billions of stellar mass sinks into a single region. A galaxy generates a basin-wide colossal dissociative pressure gradient.
So the whole region is warped.
The entire regional volume of the tension net is placed under immense structural tension, pulling violently inward toward the galactic center of mass.
Now, in a classical vacuum, things just fall toward the center of mass. But the tension net is a continuous, quasi-incompressible medium.
That's the key. We must obey a strict mechanical rule here: the conservation of topological volume. The immense inward pressure of the regional DP field cannot cause the medium to simply collapse inward upon itself into a single point.
Because the local volume is physically filled.
Exactly. If the medium is rushing inward under massive pressure, but the center is topologically saturated and incompressible, the incoming strain has to deflect.
Exactly as the radial ingress deflected into angular egress at the microscopic particle scale.
Yes. The massive inward pressure of a galaxy redistributes angularly. The incoming radial strain is forced to displace sideways on a systemic scale.
Oh, wow.
This continuous global geometric displacement forms a colossal galactic vortex. The entire regional tension net is physically swirling.
If the space itself is rotating, that's incredible. In standard physics, stars are discrete masses flying through a static empty vacuum, held on a leash by gravity. Borua is saying the stars are topological wave packets embedded within the continuous medium.
They are part of the medium.
So when the global tension gradient forces the medium itself into a massive vortex, the stars are simply carried along by the rotation of the space they occupy. Wait, so instead of stars being held together by an invisible lasso of dark matter, they are basically rubber ducks caught in a cosmic whirlpool.
That is exactly what they are. The large-scale tension gradients naturally and inevitably dictate the rotation speeds.
So the outer stars are spinning at those anomalously high velocities, not because they are tethered by invisible dark matter, but because the entire structural volume of the tension net at that radius is undergoing rotational displacement.
Yes. Global vorticity arises directly from the conservation of topological volume inside a massive pressure gradient. You simply don't need dark matter if the fluid they are suspended in is already spinning at the required velocity.
That replaces an undetectable, mystical placeholder particle with derived, macro-scale fluid dynamics. It's incredibly persuasive.
It really solves a lot of headaches in astrophysics.
But if we accept that the macroscopic world from atoms to galaxies is governed by fluid elastic tensor mechanics, we must drag the AM framework down into the realm where standard model physics claims its greatest victories.
You mean the subnuclear realm, quantum chromodynamics?
Exactly, the realm of quarks and the strong nuclear force. The standard model explicitly defines protons and neutrons as composite particles, essentially bags containing three discrete, smaller particles called quarks, held together by gauge bosons called gluons.
Right.
And we have extensive, deep inelastic scattering data from particle accelerators that definitively show incident electrons pinging off three distinct hard points of mass inside a proton.
We do.
So if Burrow claims discrete particles don't exist, how does he explain this universally accepted scattering data?
Well, the AM framework fully acknowledges the scattering data, but it completely reinterprets the structural geometry causing it. Burrow just discards the composite bag model entirely.
So what are quarks then?
Quarks are not fundamental, independent particles swimming in a void inside the nucleon. To remain consistent, the framework models the proton as a single, highly complex, unified topological knot.
Just a single fold in the net.
But an incredibly stressed one. When the continuous tension net folds under the extreme pressures required to create a nucleon, it rarely forms a perfectly simple, symmetric, spherical core.
Why not?
To balance the massive incoming dp field pressure and satisfy topological continuity, the saturated epsilon max core forms a complex, multi-lobed geometric structure.
Like a multi-centered fluid vortex.
Exactly. The manuscript uses the mathematical model of a trefoil knot. It's a single, unbroken topological circuit folded in a way that produces three distinct tight loops or lobes.
Okay, 3 lobes.
These lobes are localized strain-foci. They're the regions of absolute maximum structural stiffness within the unified knot.
Ah, I see. So when physicists fire high-energy electrons into a proton, the electrons aren't ricocheting off 3 separate quark billiard balls.
No.
They are reflecting off the 3 sharpest, stiffest strain foci of a single, continuous topological fold.
Exactly. The scattering cross-section perfectly mimics 3 independent objects because the structural tension is heavily concentrated in those 3 lobes.
So the experimental data is accurate, but the standard model's geometric interpretation of that data is flawed. Quarks are just substructures of a singular fold, not discrete entities.
That's Burroughs' argument, yes.
Okay, that elegantly handles the physical scattering data, but what about charge?
Charge is fascinating in this model.
Right, because standard physics dictates that quarks have bizarre fractional charges, positive 2/3, negative 1/3. In classical electrodynamics, charge is an intrinsic fundamental property of particle. How can a fluid elastic lobe possess a 1/3 electrical charge?
Because in the AM framework, charge is not a fundamental abstract property. Charge is simply the macroscopic measurable manifestation of advective flow chirality.
Chirality.
It is the direction and geometric magnitude of the continuous structural twist.
The chirality of the active skin circulating the core.
Yes. The ambient medium must route its advective flow around the knot. Because the proton is a single knot with 3 highly pronounced substructures, the lobes the incoming active skin flow cannot distribute uniformly. It must navigate the complex topography of the trefoil knot.
Oh, I see.
The fractional charges we measure are simply the precise geometric ratios of how that advective strain is distributed across the 3 lobes to maintain the thermodynamic closure of the vortex.
So a positive 2/3 charge simply means that specific lobe is handling 2/3 of the total fluid elastic shear of the active skin, circulating in a specific chiral direction.
Exactly. It's not magic quantum math, it's just the unequal distribution of flow over an asymmetrical object. It translates abstract quantum numbers into strict, verifiable fluid dynamics.
It's literally brilliant plumbing.
It really is.
But what about the force holding them together? Standard quantum chromodynamics uses gluons to explain asymptotic freedom. That's the phenomenon where quarks act like free particles when they're very close together, but they experience near infinite resistance if you try to pull them apart.
Right.
How does a fluid elastic model mimic the strong nuclear force without gluons?
It mimics it through the exact same mechanism that creates physical hardness. The NLEP strain well. When the 3 sublobed strain foci are resting in their baseline configuration, they sit perfectly within the deep, symmetric energy minimum of the proton's topological lock.
So the structural tension is perfectly balanced, generating 0 internal resistance. They act free.
Yes, because they are resting at the absolute bottom of the local dp field gradient.
Exactly.
But if a high-energy impact attempts to forcefully separate one of those lobes, pulling it away from the geometric center, it violently distorts the shape of the entire continuous knot.
You are dragging the continuous medium against its steep, non-linear NLEP boundary.
And the further you stretch the lobe, the tighter the continuous tension net stretches, and the more violently the restorative dp field fights to recover the knot's symmetric baseline.
If I try to pull one loop out of a complex knot, the harder I pull, the tighter the rest of the knot grips it. It is pure elasticity.
Exactly. The resistance increases exponentially the further you stretch the fabric, mimicking the asymptotic increase of the strong force.
But this creates the ultimate test of the framework. Standard physics explicitly states color confinement. You can never isolate a bare quark. If I pump infinite energy into the proton to pull that lobe completely free, what happens in the AM framework? Does the fabric tear?
It cannot tear. The absolute continuity of the tension net is completely non-negotiable. The universe fundamentally cannot tolerate an exposed edge of infinite structural strain.
So what happens?
The moment the massive energy input exceeds the elastic limit and severs the flow lines connecting the lobe to the primary knot, the severed medium instantly heals itself.
Define heals. How does a severed tensor field resolve infinite strain instantly?
The detached, highly energetic flow lines immediately wrap back upon themselves, forcefully driven by the local dp field to close the topological circuit.
Oh, wow.
The severed lobe instantly folds into a new, smaller, structurally complete knot, a meson pair. And simultaneously, the original trefoil knot rapidly reconfigures its residual strain to close its own exposed circuit, forming a new stable baryon.
So if I pull hard enough to snap it, it just instantly ties itself into two smaller complete knots. You can never isolate a bare quark because you cannot isolate a fraction of a continuous knot.
Exactly. Any attempt to sever the structural tension forces the exposed strain to instantaneously fold into a complete, mathematically closed topological circuit.
That is a staggering realization. And I presume this forced topological reconfiguration is exactly how Barua models nucleosynthesis inside a star.
Yes, it is. Stellar nucleosynthesis is not discrete particles crashing together until nuclear forces bind them. It is the forced mechanical merging of flow lines.
Inside a supernova.
Right. Deep inside a supernova, the density of individual topological knots is driven so high that the ambient baseline medium is entirely compressed out. The individual NLEP boundaries are forced to overlap continuously.
So the environment is highly quasi-incompressible. There is literally not enough topological volume to support trillions of individual localized active skins.
Exactly. Under that crushing macroscopic structural tension, the individual nucleons are forced by the dp field to merge their individual flow circuits. They must combine into singular, immensely complex, higher-order, multi-centered vortices.
And the extreme heat.
The extreme heat, the violent vibrational strain waves, acts as a topological lubricant. It kinetically disrupts the stable active skins, allowing the flow lines to interpenetrate and reknit into the deep, multi-lobed topological locks of heavy elements like iron or gold.
It's the ultimate macroscopic forge utilizing microscopic tensor dynamics.
It really is beautifully consistent.
We have systematically replaced almost every pillar of classical physics with the fluid elastic mechanics of the tension net. We have replaced solid matter with NLEP strain. We have replaced thermodynamics with vibrational tensor propagation.
Yeah.
We've replaced relativity and inertia with the active volume fraction unzipping the net. We replaced dark matter with macro vortices and gauge bosons with topological admissibility. The question that remains, the ultimate philosophical and mechanical question, is why the universe obeys these specific rules.
The underlying laws.
Exactly. Barrow isn't just making observations, he is claiming the universe operates on strict axioms. Let's dig into the rulebook. Explain how the 8 axioms collectively ensure the permanent stability of matter.
Well, the foundational integrity of the entire absolute medium framework rests upon what Barua formally defines as the 8-axiom core. These are the non-negotiable mathematical dictates of the continuous tensor field. If any of these axioms are violated, the theoretical stability of matter collapses.
Let's start with the axiom governing the healing of the quark we just discussed. Axiom 7. Apply the 8 axioms to explain why the medium avoids structural discontinuities.
So axiom 7 is closure, or admissibility preservation. It is the absolute mathematical dictate that the medium cannot sustain discontinuities. Structural strain in the continuous field must infinitely resolve into stable, closed configurations.
Why must it, though? Why can't the universe just sustain a tear? Standard physics has no problem theorizing singularities or rips in spacetime.
Because a tear in a purely continuous elastic medium represents a point of infinite potential energy gradient, which is mathematically and physically inadmissible.
Okay.
Axiom 7 dictates that any event injecting enough localized kinetic energy to sever a flow line must trigger an instantaneous reaction from the dp field. The field must cap, close, or loop that unbounded strain into a mathematically closed geometry.
Oh, I see.
Axiom 7 is the ultimate self-preservation mechanism of the universe. It is the sole reason the tension net does not fray and dissolve into chaotic, unbounded energy.
It enforces topological survival. But how does it know what shape to heal into? If I sever a flow line, there are theoretically infinite geometric ways it could fold back on itself. This brings us to Axiom 8. Describe how the 8 axioms force matter into deep energy minima.
Axiom 8 is the stability symmetry principle. It governs the evolutionary trajectory of topological forms. It states that all structural knots will continuously evolve toward deep, highly symmetric energy minima to maximize structural persistence.
So the universe is inherently lazy. It's actively seeking the path of least resistance.
It is the ultimate expression of thermodynamic efficiency within a continuous field. The dp field will exert localized pressure, pushing, pulling, and shearing until the topological fold settles into the most perfectly balanced, mathematically symmetrical configuration possible for its given volume.
Because symmetry cancels out opposing localized stresses.
Exactly, resulting in a macroscopic drop in the net potential energy of the knot.
So matter is stable because it is lazy. A proton has survived for 13.8 billion years, not because it is made of indestructible adamantium, but because it is folded into an incredibly deep, perfectly symmetrical energy minimum.
Yes.
It is trapped at the very bottom of an incredibly steep geometric valley. To unfold it, or to alter its shape, would require an input of kinetic energy massive enough to drag it up and out of that symmetric strain well. Axiom 8 dictates that the universal drive to minimize localized structural strain is ironically the architect of physical permanence.
That is precisely the mechanical rationale, and it perfectly segues into Axiom 1, which dictates the parameters of the energy traveling between these permanent structures.
Which is what?
Axiom 1 is the minimality of information principle, or MIP.
The universe mandates the absolute simplest admissible topology. How did that apply to energy propagation? We haven't even discussed light yet. If the universe is just a continuous net of knots, where do massless photons fit in?
The AM framework eliminates the classical photon as a discrete particle entirely. A quantum of light is defined in the manuscript as a topological soliton.
A solid.
It is a stable, self-reinforcing topological twist propagating through the baseline tension net.
It is a pure wave of structural strain without a frozen epsilon max core dragging behind it.
Exactly. And because of Axiom 1, the demand for topological minimality in Axiom 6, which dictates finite coherence limits, the tension net acts as an incredibly strict, high-precision structural filter.
Meaning what?
The baseline medium does not allow messy, random, or chaotic vibrations to travel macroscopic distances.
If a chaotic vibration tries to propagate, the non-linear elasticity of the net likely dampens it immediately via localized dp field interference.
Correct. The net only permits energy propagation that conforms perfectly to highly stable, mathematically simple, closed topological loops. What standard quantum mechanics mathematically abstracts as a quantum state or a discrete photon is, in fluid elastic reality, simply the lowest energy, most stable topological circuit capable of maintaining coherence while traversing the medium.
So the universe is inherently lazy. It seeks the absolute lowest energy state, the deepest divot, and the simplest possible knot. It is a fundamental resonant harmonic of the continuous tensor field. The universe filters out the chaotic noise and only permits the simplest, cleanest structural notes to ring out across the cosmos.
Exactly.
And because the baseline tension net is a purely continuous elastic matrix with zero internal particular friction, these topological solitons experience no dissipative loss. They ring across the void endlessly, perfectly preserving their localized geometry until they collide with the steep NLEP boundary of a frozen atomic core that is capable of absorbing or rerouting that energetic circuit.
The 8 axioms are not mere philosophical guidelines. They are the strict tensor calculus parameters that dictate the mechanical survival of every localized structure in existence.
From the resonant harmonic of a propagating photon to the colossal angular displacement of a galactic vortex.
Yes. They collectively ensure the permanent stability of physical reality by ruthlessly enforcing structural continuity, geometric symmetry, and the absolute minimization of localized strain.
We have spent an hour entirely dismantling the classical discrete model of reality. We have looked at Srimambarua's absolute medium framework and replaced the comforting binary illusion of solid matter and empty space with the highly demanding, hyperconnected reality of a fluid elastic tension net.
It's a lot to take in.
It is. We unlearn the concept of physical hardness, replacing it with the violent resistance of the dissociative pressure field guarding the frozen cores of topological knots. We replace standard thermodynamics with vibrational strain waves, disrupting the deep, symmetric topological locks of solid matter. We tackled the paradox of motion, mapping how the incredibly tiny active volume fraction of a propagating wave packet seamlessly unzips and rezips the fabric of space, perfectly deriving inertia and relativistic light speed limits from a pure structural drag. We scaled that tensor mechanics to the cosmos, watching the necessity for dark matter evaporate as regional tension gradients naturally generated the systemic rotation of galactic vortices.
The scale is just incredible.
And we dug into the subnuclear reality, understanding why the absolute continuity of the 8 axioms forbids the existence of a bare quark, forcing any severed energetic flow line to instantly heal into a perfectly balanced, symmetrical energy minimum.
It is an exhaustively rigorous, mechanically predictive framework. It challenges the standard model by demonstrating that you don't need a sprawling zoo of invisible exchange particles and mathematically patched gauge fields to explain the universe.
You just need the net.
You only require a singular continuous medium operating under strict laws of nonlinear elasticity and topological conservation.
It forces a staggering shift in perspective. And that is where I want to leave this deep dive. If Barua's mathematics hold true, if the standard model of discrete billiard balls in a vacuum is truly a localized illusion, masking a continuous tensor field, it fundamentally rewrites our physical relationship to the cosmos.
It connects everything.
Literally. If this framework is correct, everything from the complex molecular chains in your DNA to the wood of the floorboards beneath you to the light years of empty space separating our solar system from the Andromeda Galaxy is composed of the exact same unbroken singular fabric.
The tension net.
There is no void. There is no separation. You are not a discrete object sitting inside the universe isolated by an impassable vacuum. Mathematically, topologically, and physically, your body is a highly synchronized, violently complex fold of the universe itself.
You are the universe.
The fluid elastic flow lines that weave your atoms into macroscopic locks stretch continuously, without a single microscopic tear or spatial gap, across the interstellar medium, right into the burning, topologically saturated core of the sun, and out to the swirling macro vortices of distant galaxies.
Beautifully said.
Next time you look up at the night sky, you need to abandon the idea that you are gazing across a great emptiness. If the tension net is real, the fabric comprising your eye is physically, structurally contiguous with the fabric burning in the stars. You are physically touching the cosmos. Keep questioning your reality.